Good morning, James.
Good morning.
Are we going to talk about switches and wiring today?
Yeah.
We're going to talk about understanding how to install a sensor switch into a laundry room. I always start with theory, but I've tried to lay it out very simply to lay the foundation for a very quick install. So what we're going to do today is we're going to teach you how to fish when it comes to wiring. Now, I'm no expert, but I learned from this from my dad when I was a kid. And most household wiring is pretty simple. All right. Ta-da! Thumbs up, JMO. All right. Okay, good morning. I'm going to explain to you the basics of wiring so you can understand how to install a occupancy sensor switch. I'll first explain it as a two-way, which is a standard switch in North America, and then I'm going to really go to a three-way because that's what I'll be installing. The two-way is just a simplified of a three-way. Okay, let's talk about North American Romex. This is what's in every house in America and Canada since 1950 on. There are three basic varieties. There's ones with 2 wires and ones with 3. Actually, there's 3 and 4, but I'll get to that. It's commonly referred to as 12-2, which is 12 gauge, or 14-2, which is 14 gauge. It's just a slightly smaller wire. Then there's 12-3 and 14-3. So 2 and 3. Focus on that. So if you just take a piece of 12-2 and stripped it back, what would you see? You'd see a black wire, a white wire, which I'm using silver in this video, and the exposed bare copper wire. So you've got your hot, which is where the electricity is coming from, your return, which is where electricity flows back to, which is neutral, and ground, which is a safety wire. I'll explain that in a minute. 12-3 has those same 3 wires, hot, neutral, and ground, except it adds a second hot. So now we have 2 sources of energy. So what is that exposed copper wire for? Simply put, it is a safety wire. People used to get electrocuted on electrical devices because the hot somehow would start touching a part of metal that you could touch with your hand and they would get shocked. So to fix that, what they did is they added a second safety wire that's ground. Where does this ground come from and how does it work? Well, if you look at a very simple drawing here, I have the power coming in from the power company. You've got hot and neutral coming into your breaker box. You have the power, hot, going through a breaker that if the energy goes up too high, it throws the switch open, disconnecting the circuit. So that power would go through a typical wall switch, which I've shown here, and then it would go on to, let's say, a light. Very simple. You have the neutral return path through the breaker box to the power company. So where the earth ground comes in is that at your house, there is actually a metal rod that is pounded into the ground outside of your house. There is a wire going from that to your breaker box. And I'm showing a couple terminal strips here because the neutral from the power and the earth ground from outside your house are used by many circuits. So I'm just showing a single circuit tying to it, but in reality there's 20 or 40 of these hooked to each of these 2 junction points. So the earth ground goes on and it's tied to the outside metal of the switch. So if the hot starts touching the outside metal, it would instantly short circuit to ground, blowing the breaker open. Similarly, that ground continues on and is connected to the metal, if any, around, say, your light switch. So that if the hot touches the metal of where the light bulb screws in, for example, it would short the ground, thus throwing the breaker and disconnecting the circuit so that you would not get hurt. So let's talk about how a switch can turn a light on. So at your wall, you have hot and neutral. The hot goes in the plug through a cord that has both wires, and then they would come to where your switch is. The switch simply connects and disconnects the electricity from the light. So you can see here the switch is off, therefore the light is turned off. And your neutral, no matter what state the switch is in, is always connected. So when you connect that switch, the hot can now flow to the light, making it come on and flow back. That is what is referred to as a two-way circuit. It's two ways, either on, way 1, or off, way 2. These are also referred to as single pole, single throw. So you pull the switch and it opens one connection. Single pole, single throw, two-way. So what is the difference between a two-way and a three-way? As I just discussed, a two-way is either a state of on or a state of off. 2. A three-way is intended to be used with a second three-way switch to produce 3 different ways. So you can have off, on, or on. So you can see that there's an extra wire on a three-way. And I'll explain why that's so important. You will find many videos on YouTube explaining three-ways, but I need to explain the basics so that you can understand how I'm installing a sensor. A three-way has 4 possibilities. 1, 2, 3, 4 cross. If you look down this drawing, what I'm showing is here's the incoming power, here's switch number 1, here's switch number 2, and then here's power to the light. This column right in the middle, they are referred to as traveler wires. You'll see how they work here. So just imagine the 2 three-way switches. Both switches are up. You can see the power comes in, goes across this red wire traveler down, and turns your light on. Now, let's say you turned this switch off, the power has nowhere to go. Now, you walk to the other end of the room, for example, and you turned this switch down. That completes the circuit that was broken here and is now completed, and the light's back on. Then you walk back across the room and flip the first switch back up, and again, you can see the power is broken. So you can see there's 4 possible states. This is how a three-way can turn a light on from either end of the room. The important part for today is to determine which of the 2 boxes in your home has power. Which of the 2 boxes leads to the light. So here's the project we're doing today. I have a laundry room. I'm tired of turning the switch on with my single hand every time I walk in to get the laundry or to flip loads or feed the dog. And then I have to turn it back off again. It's tiring. So this is what we're going to do. So here's my laundry room. You can see we come in from the kitchen here. Laundry is here. There's a stationary tub here, and then you can go outside. So power comes into the first switch. That would be 12-2. 1 hot, 1 neutral. Then out of that three-way switch, which is right here, switch 1, we have 3 wires. 12-3. Those are the travelers. The hot 1, hot 2, and neutral. Those all come across to switch 2. That is the second three-way. Then the output is just back to 12-2 because we only need a single conductor to turn the light on. So let's talk about occupancy sensors. I drew a brief anatomy here to help understand. When you buy a sensor, you need to know first if you're putting it in a three-way circuit or a two-way. The reason is that cheaper sensors are simply like this. They are a single pole, single throw switch that can turn the light on or off based on if they sense movement. Three-way sensors have an extra input, I'm going to call remote, that can be used to tell this to turn on. So make sure the one you buy says it supports three-way. Now you can use a three-way in a two-way circuit by just not connecting the remote wires, just depending on what you're looking to buy. The difference here is that a three-way is wired up a little different. The occupancy sensor that I'm putting in has the switch, single pole, single throw switch inside of it that turns the light on. Now it can turn it on from one of 2 inputs. It can turn it on with the input from the sensor, or it can turn it on if it senses a signal on the remote wire. How is that remote wire commanded? The remote switch, switch 2, will connect the remote wire to neutral. When this sensor sees that wire go from no input, or what we call floating, to a hard ground, it will also turn that light on. Now what's nice about these sensors is that they have a timer, so after the timer that you can configure expires, it will still turn the light off. And a lot of these in the instructions have multiple ways you can set them up, but I'm just keeping it simple. And if you look at the sensor here, it basically has two things that you see, a motion sensor and then a manual switch. So I can manually turn it on from this end of the room or that end of the room. Underneath this button, which pops off, is a couple of control inputs for allowing you to configure the unit. And some units, there's a press and hold sequence, some of them have lights, there's all different ways. Just read the instructions. So what is this going to look like when I'm done installing? In my laundry room, I have 12-2 power coming in. Here's my first switch box. I will have the sensor hot to the line power. That hot will come out through the 12-3 over one of the traveler wires into switch box 2. I'm just showing a junction here between that piece of Romex, that's what this little square thing was, my idea of showing a junction like a little wire nut, and then that would go straight up to the light. Then the neutral comes into the switch box, connects to the sensor, but it also has a junction and goes through to the second box, which is junctioned and goes up to the light. So for the remote input, I'm just showing, I believe it's a blue wire, we're going to connect that wire to the second traveler wire, and on the other side, instead of that traveler going to a three-way switch, it just goes to a two-way switch, which connects it to neutral. The last thing that's very important is to run that ground wire. Often people just leave them and don't hook them up. It's easy to do that. You'll never know it's not hooked up, but you could get hurt someday. Always make sure you follow the regulations and rules for hooking up electrical. Where I live, if the homeowner is doing the electrical work, you don't need a permit, but other states vary. That ground wire is junctioned in the first switch box and ties ground to the sensor switch. Then it goes across in the 12-3 with the travelers in neutral to the second box, which is junctioned again and is tied to the ground lug of the single pole, single throw switch. Then that ground continues on and hooks to the ground terminal on the light, protecting the light. So you can't get shocked off this switch, and the light. This is what we're doing. Now, if you're not sure when you open these two boxes where the power's coming in, the easiest way to do that is to use a multimeter. And I will demonstrate that as well, how to figure out what is what. It makes it easy between these two boxes because you know you're going to see a 12-3 come out, and it's going to be hooked to the switch that controls that light. So you can figure out what the 12-3 is. You can figure out this Romex, and you can find this Romex because that will also be hooked to this switch or be hooked to that switch. All you need to do is figure out where the hot's coming in, and we'll use a multimeter for that. Okay, so let me quickly explain how we will use a multimeter to determine which side is hot. This is a very typical multimeter. It does the basics. All a multimeter really does is measure voltage, whether it's DC or AC voltage. So for today, all household wiring everywhere in the world is voltage in AC, alternating current. So to measure the voltage, all we need to do is select the voltage AC measurement. Voltage with the tilde. This is a DC voltage, but you don't want to do that. You want AC. The input for voltage on this multimeter, this one's good for 750 volts AC and 1000 volts DC. So if you select the wrong measurement here, it won't hurt the meter. You just won't get a good measurement. So make sure you connect your cable to common or ground, and then the voltage pin. This pin over here is for measuring current. You see 10 amps, that's current. We don't want to measure current, we just want to measure voltage. If you don't own a multimeter, get one that comes with these little alligator clips. This way you can clip it on the wire. It's pretty well shielded and you won't get shocked. So what we'll do is we will open the two switch boxes, remove the two switches, and then connect this to neutral, connect this to a hot, and turn the breaker around and see if we get a reading. If we don't, then we'll move on to the other box until we find the hot lead. That's where we would start our wiring. So here in North America, we have 120 volts AC, so I would expect a number around there. So you can see right now, I have the ground black wire tied to the neutral pin on electrical cord. the hot lead, I'm just going to probe the hot pin. I'm measuring about 122 volts AC. That's fine. When you get readings of 50 or 60 volts, that's a backfeed or something. You're looking for a number that's pretty close to what your country uses. North America uses 120 volts AC, so there you go. I'm on the hot circuit in my shop. Now I'm going to go find it upstairs in the switch box. So the first thing you always do on electrical is you turn the power off. We don't want to get shocked. If you don't know which breaker it is, often houses, the electrician that originally built your house will label your box. If you don't know which breaker it is, have someone stand in the room with the light on, and then start flipping breakers on and off one at a time. You will not hurt these. I happen to know it's 14. I can go in now and check to make sure that the light is indeed turned off. So I'm going to do that next. I'm going to go in, remove the two switches, find both of the 12 twos that could be power, and use my multimeter to determine which end is the indeed hot end. So here is switch number 1. I removed the switch because the other box for switch 2 has a neutral in it. They cheated in my house and just used 12-2 using one of the neutral for a traveler. Now you can get away with that, but you have to mark it that it could be hot, and I'll show you how to do that. So what I've done is I've clipped on what I believe is the hot lead, because I can see a junction here and hot going back out somewhere else. So I put my multimeter plus on what I believe is the hot, and you can use neutral or ground because they both end up in the same spot, the earth, for your negative lead. So I'm currently reading 0.5 volts AC. So I'm going to check that by flipping the breaker on. Now when I come back and look, I'm reading 122 volts AC. So I know that's the source of power because the switch on both ends is disconnected. Since we're going to be using a white wire for a different purpose, you can use colored electrical tape, such as this. You can buy a pack like this at the hardware store for $3 or $4 to change the color on the wire that you're going to repurpose. This tells an electrician or anyone else that when they open an electrical box that a white wire might have electricity on it, and be careful, or vice versa. It also helps you figure out a blue wire goes in there and comes out somewhere else. I know this is my hot, this is my neutral. These are the two wires that go over to the other box, plus there's a ground right here. So the first thing I'm going to do is send hot from the remote box to the sensor box. So to do that, I'm just going to tie the two blacks together. That will just send power to the other box. I know you're supposed to use lineman's pliers to do this, so you get a real nice twist. I've never had any problems. I'm not going to worry about it today. So now I have power, once turned on, sent over to the other box. So this will be my signal wire for the remote input. So what I'm going to do is I'm going to mark that it is actually indeed a blue by taking a piece of blue colored tape and wrapping it around. Just need to signify that it's something other than a neutral. There. Now I'm going to strip, take my strippers, put a bend in it so I can get it around the terminal of my, and of course I have to pull the switch out of the. Okay, so now I will connect one side of my switch to this wire. This will be my signal wire. Always make sure, since the screw turns clockwise, that you wrap it clockwise so that this hook doesn't open up when you tighten the screw. Now for the other side of this, I'm just going to tie it to a neutral. So I'm going to use this neutral for my switch closer. So I just have a small spare piece of Romex. So I got my wire, I stripped the sheathing off, cut down a slightly longer than I need piece. So I've crimped it shut. I always do this. you really want to get the screws tight, don't use a Phillips, use a flathead. You can put a lot more torque with a flathead. I'm sure this will be fine, but I don't ever want to have problems. So there we go. Now this is being used as a neutral, so I'm not going to recolor that. Only recoloring what the purpose ones that I'm changing the purpose of. Let's take this wire nut off. There we go. Strip off a small portion there. And same as the screws, when you put wire nuts on, you want to make sure that you twist clockwise because the wire nut screws on clockwise. If you don't own any wire nuts and you're going to start doing wiring projects, I highly recommend you just go get a small container of mixed size wire nuts. There's usually this size, a little bit larger red one, and a little bit smaller orange, and really small blues. So now my signal should be complete. Now the ground I noticed is twisted together, but all wires need a wire nut or a crimp. So I happen to have green ones, but you can feed a wire through the top. So I'll just put that on just to make sure I never have any trouble with my grounding. There's that. These wires, once you get them in, you can just jam them in. When you're doing a lot of wiring, I often use the butt of a hammer to push them in. And I'm going to leave it like that just until I'm sure that this actually works, because there's nothing worse than taking it all apart again. So I'll test it out with power temporarily. Once I'm happy with the switch workings, then I'll finish it. So now I'm on the second switch here. You'll see I have the bare copper ground. I've got two blacks and I've got a white. But if I actually look inside, I can see the Romex down in here. The white wire from that Romex is already tied to a neutral. That means that is the neutral for the switch. So I know that this now is the power to my overhead light, which means that these two wires are the travelers. So I have a black traveler and I have a white. They should have labeled this one red when they built the house, but this house is 25 years old. Maybe the rules are different now, but they should mark it. So what I'm going to do is I'm going to take a little bit of my blue tape and just mark that it's the traveler. In fact, it's the traveler for the remote from the other switch. This is going to be hot. Right? See, this is the hot, this is the light. I'll keep that separate. Here's the switch I'm installing. Different companies have different markings, colors, whatever. Here's the switch I'll be installing. You can see there's a legend right on the side. Sometimes it's on the instructions. But you can see here, black is hot. That will be the hot from the other box. White is my neutral, and there is no white on here, which means I don't need neutral. Red, primary load output. So this will go to the light, the red. And then green is ground. We got that. We'll hook that up to ground. And then blue is optional. See, it's not bold. It's optional. Three-way traveler. There's two yellows that come out too, but you don't see them here. That means that there's multiple versions of this switch. This one's just made by Cooper. Lots of different companies make these. Instructions, sometimes it's a piece of paper folded up inside the box. Sometimes it's like this, printed on the side. Sometimes the box itself is the instruction. Here was the box for a three-way switch I put in a couple weeks ago. When you break the box open, it shows you how to install the wires, shows you what pins do what, and it has some instructions for you in case you're new to installing switches. So to attach these stranded wires to a solid wire, you're going to wrap the strand around and put a wire nut on. Keep in mind that if you look at the inside of a wire nut, it's only about half as deep as the whole nut. So the first thing you want to do here is cut some of the, if you have long wires here, you might want to cut them down a little bit. Another trick that I figured out years ago, first starting to work one-handed. This might be useful for people new to electrical. So it's really tough to hold the wires together. So what I've been doing for a long time is putting a zip tie on. Line tighten those up. Strip them. So I'm going blue to blue. There's my remote. Now you saw me hand twist these on. There's nothing wrong with that. Or if you can use one of these my dad gave me. Nice and tight. And cut that zip tie off. Make sure you don't cut your wire. And I'll just keep going. So the next one is going to be black, which black is hot coming in. Hot coming in is on this traveler. So let's do that. When you're doing wiring, don't forget that it's hard to add wire back when you cut it off. So especially in older homes, you'll pull a box out and you'll notice that you barely have enough wire to even reach out of the box. You can see this is a little too long, so I'll cut the stranded wire off. Switch. Get started. There we go. Okay, that one's done. The next thing is the load, which I believe is red. Yep, load primary, load output. Okay, let's do red. I usually put those zip ties on pretty loose. Just something to help hold it there. And then I tighten them up afterwards. Also gives you the flexibility to push that wire back a little if you need to. Again, that stranded wire is far too long, so we'll just cut that off. That's the end of that. Cut those off. That one. That one there. And the last one is the ground wire. Which everyone should know where that goes now. It goes to literally a metal pole pounded in your backyard into the dirt. Guess it doesn't work on this type. Have to write the company. Well, that's not tight enough. Okay, well, let's just go get another one. It should be to the point where you can't turn it anymore without twisting the wire. So the wire's starting to twist, that's tight. So I should be all hooked up. So I'm going to go turn my breaker on temporarily and test that both switches work. You don't need to worry about the motion sensor right now. We're just going to test that this switch works and the other one works. Tuning the sensor we'll do later. I'll show you that next. So now that I've tested my power on to make sure that I can turn the light on from either side, I'm just going to jam all this stuff in here. There's really no right or wrong from what I've learned over the years. The way to do this, but the hard part is making sure that you can stick the switch in. So oftentimes you kind of have to jam the wires pretty far back to get your switch in. Easiest way to make sure it'll fit, just jam the bad boy in there. And it's still hitting. I think I got too much back here. Okay. Because I have power turned off to this whole box, I don't have to worry about getting shocked. So I'm not too afraid here to stick my fingers in an awful lot of wire nuts, but that's kind of sometimes how it happens. And there we go. Okay, so now that I've got that jammed in there, I start at the bottom. It's easier to get the top started after you get the bottom started. You'll notice that there's a little slop in here. These screws are supposed to be slightly loose. The reason is so that you can get the outlet plate on without fighting it. So I'm putting outlet plate on here, and voila, you're done. Note there are two types of plates here. There's a very soft plastic type called unbreakable. Those are real bendy. No matter how hard you tighten these screws, the plate will never crack. The downside is they don't look that great. I don't know what this is made out of. I believe it's fiberglass reinforced plastic. They look a lot nicer. They stick out a little bit further, but if you tighten these screws too tight, you'll crack it. So snug. Also, you'll notice all my screws point up. That's just a visual aesthetics thing. You can do them all sideways or all up, doesn't matter, but it looks nice if they're all the same. I always make mine vertical because the sun shows less shadow when they're in the vertical position. So I don't know. That's the way I learned. During the test phase, when I turned the power on briefly, I discovered that my remote switch wasn't working. And I don't have the instructions for that sensor anymore. I put that one I moved 5 years ago. But when I took this apart, I noticed that the other side of the remote was tied to the ground wire instead of the neutral. I figured it wouldn't make a difference because inside a breaker box they're tied together anyways, but apparently it does. So I found the switch to be more reliable when I was testing it. So I moved it from the neutral down to the ground wires. So since I'm using a white wire in a ground situation, again, you don't have to do this, but I think it's a good idea. Just put a piece of green tape around it. And everybody knows that you're still using it as a ground. Might help someone down the road. So now they can see it is meant to be a ground up to the negative. So when you flip the switch and it connects them, it's connecting that remote from the other side to a ground. Now I'll just jam this in here. Make sure the writing on the switch is the right way up. Reinstall the cover. And you'll notice that the screws for covers are very short. They're supposed to be. There we go. Remote switch. Cool. Here's my sensor over here now. On. Off. Now the last thing I'd like to show here is, this is just this style of switch, but I've got several different colors. There's two adjustment nuts here. This one here is for sensitivity. So how bright do you want the switch to trip with ambient light? If you only want it to trip at night, you would turn it one way. If you want to trip it all the time, even in the daylight, if it gets motion, you can turn it the other way. And you can tune this so that the darkness level that you desire light, it will actually come on. The other one is just how long it stays on. I have it set for 5 or 6 minutes. I don't know. It's just a knob. Some switches, this outer plate has to be off to get access to them. Sometimes they're in the sides, but the good ones are in the front. I can change this whenever I want without having anything but my finger and a small screwdriver to tune the knobs. I know this one's already adjusted correctly, so I want it to come on all the time. It's a pretty dark room, So as an addendum to my original explanation, I determined that because the sensor, which is here, this is the actual sensor itself, I determined that since this sensor does not have a neutral, it actually uses the ground to sense this switch. I ended up having to cut this and route it down to ground. Now it did work on the neutral, because I know the neutrals are tied in the breaker box, but it seemed to be more reliable. And that's how I had it originally wired up. Like I said, I put this switch in 5 years ago, and I don't have the instructions anymore. As an addendum, I thought it might be helpful to show the different sizes of wire nuts that you'll see in a home. These two are the same size, the difference being that this is for tying usually 3 to 5 leads together. This one is for tying grounds together, and the color kind of helps you, but what's special about these is it has a hole drilled in the end, so you can, when you're tying grounds together, you can run one long out here to a switch, and then the rest are tied up inside there. These yellow ones are usually two connecting together, two hard wires, like in household wiring. These three, usually you'll see those when you have a home wire, a solid wire, and you're going to attach a stranded wire like what I did with this sensor. These will work, or that. Sometimes you get these two smaller sizes. They're handy every once in a while, just depends. Don't use them very much. The last one you might encounter, which I had never seen till I moved to this house, was these. And what it actually is it's for connecting multiple ground wires. They'll twist all the ground wires together, slide this over it, and crimp it, and then have one of those wires extra long going to a switch or an outlet. So basically takes the place of this with this. They're kind of a pain to get off. I just take a pair of side cutters and cut this way and peel them off when you need to add a ground wire. I prefer these because it allows you to change it whenever you want, especially if you're living somewhere for a long time. Let's talk about wire strippers. I'm sure most people are familiar with a stripper like this. It has all these different size gauges. Household wire is usually 12 or 14 gauge. These are for crimping, crimp connectors up here and whatnot, and there's a little cutter up here and down here. You can absolutely use these, but there's an easier way. If you do a lot of wiring, you might want to go with something like this. This is what electricians use. And actually, I used my first pair so much I literally wore them out. I wired up 2 whole houses, the basements, and I wore them out. So what's nice about these is that if you look, it says 14-2, 12-2, 14-12. And what's that for? You see the opening here is perfectly sized to strip the Romex off a flat piece of Romex. And then if you want to strip an individual lead, that's what these are for. It also has a pair of pliers at the tip for grabbing the wire and curling. And the two most common sized threads are right here in the handle. And most people don't know this, but you can put a screw through this, the threaded side, and then if you want to cut it, and then the new length you want should be in between the jaws. Once you screw it in there, you close them, it shears it off, and then you open them and you back the screw out, and that fixes the thread so you can screw it into whatever you're doing. Also very useful. This one does that too. And you'll see here 632 and 832. These do 632 and 832, but they also do several other sizes as well. So again, just depends on what you prefer. These are great if you're doing a lot of wiring because stripping the sheathing off is just so much easier. Now let me explain why what you saw when I actually put it in was slightly different. The house I live in was built in 1994. I don't know if the electricians were cutting corners or not, but they didn't run the traveler wires with 12-3. They ran 12-2 between the two boxes. And I'm not a certified electrician. I don't know, I don't know all the nuances of the rules. So what I did instead here is the hot in box 1 that originally powered the switch was passed through to the sensor. Then I took the ground, tied that through the remote switch to the remote input. And if you recall, I put blue tape right here on a white wire. So anyone who opens these boxes in the future will realize there's something special about that and to pay attention. The neutral from the power coming in here didn't go to box 2. In fact, that neutral went nowhere. It did go on to power something else. There was a second connection to it, but it didn't go to the light. What they did is in box 2, because there was another circuit that ran on the same power source as my light, they brought the ground and neutral into that box 2 for the light on a second connection. It may have come from this, I don't know. So they had the neutral going to the same neutral for the other light that second box powers, which is an outside light, and it uses the same ground. So what I did was, I've got my hot from box 1, I've got my remote signal from box 1. I connected the ground of the sensor to the ground for the light, which is the ground for both lights, the laundry room and the outside light. And then this was the load output. It's red. I tied it to the black for the light. And you can see here, 1, 2, 3, 4 wire nuts I added in this box. 1, 2 wire nuts I messed with in box 1. And you can see that the negative and ground are coming from the second circuit for the outside light. You have to understand that if you've ever worked in a breaker box, all the grounds tied to a single point in the breaker box. That is like a terminal bar. So if you looked in a breaker box, what would you see? You would see a strip that looks like this. What you're going to have is, I told you, there's literally a grounding rod pounded into the dirt. That wire comes in here. It's pretty big. It's a braided wire. And then all your grounds for all your circuits, you'll have tucked into one of these with a screw holding it tight, tying all the grounds together. And in a breaker box, every ground for every circuit in your entire house goes to the same spot because it goes down to the single earth connection. All the neutrals in a box will be on one like this. Might look from the other side, or it might look like this, but it's going to be a strip like this. Usually they're a lot longer. This was for a sub panel I put in, so they're short. Usually they're twice as long. So all the neutrals, because the neutral fundamentally comes from the power company. The power company's neutral, again, would tie into a lug like this, and then all the neutrals from all your circuits would be here. So the reason they could get away with that is of taking ground and neutral from a different circuit, potentially, even though I found out that they all come from the same breaker, but not in running through the traveler, was because these two go to the same spot that these two in the breaker box. I know that's probably going to be confusing to some people, but you have to understand that in the breaker box, fundamentally, this neutral does indeed connect. Just like in the breaker box, this ground will connect. And thereby, current can flow from the breaker, wherever that is, through the light and back down to the box. You just can't see it looking in the boxes. So I hope that this gives you a little bit better explanation of expectations versus reality. Often things don't go the way that you plan, but you can make it work. I hope that helps you understand a little bit of electricity. I understand that people get scared off because they think it's dangerous or too complicated. It isn't dangerous as long as you turn the power off. The worst thing that could happen is when you turn the breaker back on, the breaker instantly blows. Now you know you have a bad connection and you messed it up. Keep in mind too, if you take on a project like this and you can't figure it out, you can just put it back the way it was and it'll be fine. When you pull things out of the box, take a picture with your phone. I do that all the time. When I take things apart, I take a picture before I actually start taking screws out of things that are small. You can always put it back. So I hope you can take this newfound knowledge and use it to replace switches or to put sensors in or do other very simple household wiring. It's not that hard as long as you turn the power off. So have a good day. Bye.